dan worden of zo.
Is the microphone on? Yeah, perfect. Thank you. I hope you had a good coffee break. Yeah, it was nice to hear you talking just before we restarted now, or reconvened, having this talking. At Zoom, it was always silent then during coffee break, so fantastic. Let me present now our next speaker. It's Ricardo Weewer. Maybe doesn't need a lot of introduction, but anyhow, he started here as professor in fire service science at EFV in 2011, and he also has a big and a large experience in practical research and also rescue actions and so on when he was fire officer in Amsterdam and also head there. So, and he did metal science at Delft University also. And I see we differ 1 year, so we are almost the same. And I had the pleasure to have him on Zoom for a PhD defense in Lund. So, but I hope he can come in live also one day. So he will talk about, let's say, experimental study on techniques for smoke cooling. So, Ricardo, please.
Thank you, Patrick. We just saw how much smoke a small sofa can produce inside a building. And that is, of course, for the fire prevention, very interesting. But the firefighters that have to go in, they have to cool the smoke. So, and the question is, how do they do that? And what I will do is give you a brief overview of our big experimental study that we did into smoke cooling. And also give you some brief conclusions about a literature study about the same subject. But first, let's start with a short movie.
In firefighting, know-how is vital. There is no substitute for an understanding of fire behavior and an understanding of your equipment. You must be able to focus this know-how on fire conditions as you find them if you are to be a top-notch nozzleman. Will adjust your fog pattern to protect you from the heat, but you can and should improve the effectiveness of your protective clothing by wetting down. Protective clothing does an excellent job of shielding you from falling debris and heat. As a nozzleman, you should know the 3 methods of attack. If the fire is small and heat accumulation is low, you will probably make a direct attack with a relatively straight stream. Intense heat may force you to use either the indirect or the combination attack. With the indirect attack, you spray only the heated overhead. The indirect attack continues steam production over a somewhat longer period of time. This can be used to advantage in a complex situation where several lines are necessary and their coordination is a problem. In any attack, the maximum heat absorption of water is utilized only when the water is converted to steam. Efficient firefighting requires both knowledge and skill. The degree of efficiency is dependent on the individual's ability to apply basic principles to the situation he encounters.
So you see, firefighting is not that difficult. You know, they already did it in 1961 like this. And as a matter of fact, that is still a method that can be used. I will go into that later on. But first, so what am I going to do? I'm going to talk to you about our experimental study, but not too deeply, because we have a breakout session where we have my colleague Thijs Geertsema, who knows everything about the experiments, in combination with Lars Axelsson, who has a lot of practical experience. So I invite you to go to that breakout session to ask the difficult questions and ask me only the simple ones. Yes? So the objective is very important. The objective of the study is very important, so that's why I go into that. And then some results, some conclusions, the literature scan, because after we published the first results, there were a lot of discussions about the results and about the conclusions, so that's why we also performed a literature scan to see what is found in the literature about smoke cooling. And then I have some things to think about for you. So why did we do these experiments? Well, a few years ago we had the International Fire Instructors Workshop here, and there were a lot of experts on firefighting, and we determined 8 non-negotiables, and one of them is to put water on the fire as soon as possible. Yes, that's very easy, but if you cannot put the water on the fire as soon as possible, then you need to cool the smoke. Cool the smoke is one of the non-negotiables you have to do if you cannot directly attack the fire. But that is easy. Everybody was agreeing on that, on these 2 facts. But how to cool the smoke? That is the discussion. That is a global discussion, because a lot of people say that you should use pulse techniques with small droplets to cool the most effectively. In the United States, however, they use the straight streams. And we had a lot of discussion between the experts. Is the straight stream also effective in cooling the smoke? And they say no. And that is, of course, interesting, because the pulse techniques, they are not very easy to instruct and to train. Our instructors in the Netherlands, they complain about the little time they have to instruct and also to train these techniques, and they ask me, can it be done more easily? So that's why I thought that maybe the straight stream technique that is used in the United States could also work in the Netherlands. And that's what the discussion is about, and that's also what our research was about. But before I start telling you about the experiments and what was the conclusions, it is maybe important to put some context into these experiments, because since we published the English version of our results, there was a lot of discussion in the social media, and the discussions, in my opinion, are mostly about what our study was not about. So I think it is important to tell you what the study was about. So at first, in the Netherlands, and I know there is some foreign colleagues here from Germany and also from Belgium, in the Netherlands we have implemented the basic principles of firefighting. And the basic principles are based on our former research and also on these non-negotiables that we agreed on internationally. So, very simple. We consider the fire triangle. We use the fire triangle to put out the fires. That seems to be very easy, but in the past we forgot the oxygen side of the fire triangle. So we left the doors open, we smashed the windows, etc. So we gave the fire more oxygen, and we were surprised that it grew. So that's what we don't do anymore in the Netherlands now. So stop and think is we give each other a little bit more time to see if the situation is realistic and is also in according to our expectations. Do a 360, it's a non-negotiable. 3 questions. Do I know where the fire is? Can I reach it? Do I have enough water? Then we can put it out from outside. If not, then we go defensive. At least defensive. And in some situation, we can also go inside the building. If it is a small compartment or a small building, we can do an internal attack. What is very important is the door control, fire triangle, but if you cannot put water immediately on the fire, you have to cool the smoke. So that's very important if you go inside. So that is why we did the study, is how to cool the smoke the most effectively and in the easiest way. That is very important. So how did we do it? So this is an impression. We used a situation that is comparable to the research that was done by the Fire Safety Research Institute, UL, in the United States. They have the buildings. Everybody that know the reports from them know that they always use a long hallway with a fire compartment in the end. But it is always made of wood or made of steel. And we chose to do it in a stone building, because in the Netherlands we don't have steel buildings, we don't have wooden buildings, so we use the stone buildings. And it is a stone hallway made of stone with a fire compartment in the end. We created a lot of smoke in the hallway, and the idea is that you cannot put the water directly on the fire, but you have to cool the smoke. And in that hallway, we had a lot of sensors, temperature sensors, radiation sensors, also carbon monoxide, all kind of sensors to measure what is happening. And we instructed the teams to do exactly the same every time. So, and we used different techniques. So this is an overview. I will have a movie later on. So this is what happens. We compared the 3D pulse technique, like we educate our firefighters, and the arc technique, which is comparable with the flow and move technique, which is used by UL in their studies, which will be like you have a straight stream, you open the nozzle, and you make a U form, ceiling and walls were wetted, and that's how you proceed, advance to the fire, and at the end you extinguish the fire. We use different flow rates, so high pressure flow rate, 120 liters a minute, and low pressure with 2 flow rates, because sometimes we use the 450 liters per minute because we needed to put out the fire. So we use 2 flow rates in the low pressure, and since some of the fire service regions in the Netherlands also have the 1.7, the CAFS system, we also tried the CAFS. These techniques, they were performed by experienced instructors on these techniques. In this movie, we show, it starts a little bit late, but it is okay. So this gives an overview of what happens. So you can see the fire lit, and these cameras, this is the camera halfway, and this is the camera at the beginning of the hallway. And you can see the hot smoke entering the hallway, and every experiment started when the smoke layer was stable. And to your knowledge, the door was left open, and I will explain later on why we did that. So after the smoke layer reached a temperature of 250 degrees near the door opening, the team enters and uses the technique proceeding through the hallway. We see the temperature rise and the smoke coming out. So there's really a lot of smoke coming out. We had a fire load consisting of pellets, and the heat release rate when the doors would be opened was about 8 megawatts. But of course, when you close the doors, the heat release haze will decrease. And you can see the temperatures now. So that is near the fire, and this is near the opening, the door where. And you can see the team entering. And in this situation, they did a pulse technique. You can see the water spray here. What is interesting that we noticed on these movies, that even the very experienced instructors had a lot of problems not touching the walls and the ceilings. While the principle of pulse techniques is that you spray inside the smoke layer without touching the walls. And that is also one of the criticisms that people with the straight stream and the arc method have, is that you will create a lot of steam, and the steam will probably hurt firefighters. So that we didn't see a lot of steam here. We also didn't see a lot of steam from the arc method. That is a very important conclusion. So, I think this is, you've seen it, yes? Okay. This is our drone. You can see the heat in the fire compartment there, over there. So let's go here. So there's one thing that at least I have learned, maybe you as a fire engineer already knew it, but what we measure is the temperature inside. We had the temperature trees on several places inside the hallway to measure the temperature. But in fact, it is of course not about the temperature alone. It is about the energy. Because what we do is we have a hot smoke. We put water in the smoke, and the water evaporates, which takes up a lot of energy. That is the idea. And so what we did is we compartmented the hallway and calculated the amount of energy inside all these compartments, in the hot side and in the cold side. And what I learned, of course we knew, but we not always think about it, that when the water evaporates and forms steam, the energy has not gone. The energy is in the steam. The temperature may decrease, but the energy is still there. And that is probably one of the problems that we didn't foresee. So you have to have an exit for the steam. The steam has to go out, because when the steam goes out, the energy has gone. And that is the most important. If the steam cannot go out, then it will probably condense on the coldest surfaces that are available, which may be the firefighter. So when it condenses, it gives off all the energy. So the firefighter gets hot. Yes, that is, maybe you already knew that, but for me it was, again, it was very nice to know. But so it is very important to leave the door open as soon as you start extinguishing or putting water in the hot smoke. That is something very important to know. Door control is therefore not only keep the door closed when you go in, but it is open the door when you start using the water, because you have to get rid of the energy. Okay, maybe I tell something that you already knew, but for me it was rather new. So when you look at the energy change and you compare the different methods, you will see this. So this is the baseline. This is when you do nothing. You can see that the energy on different places in the hallway, the colors correspond to different places in the hallway. The light blue is very close to the fire, and the dark blue is very close to the doorway. Yes, the exit. So you can see that in all places, the amount of energy we calculated in the hot zone, so on top of the hallway and near the ceiling, increases, And when we start extinguishing with different techniques, you can see that it always, because there is a minus upstairs, yes, so the energy decreases when you start using it. So let's look at this just for you, for a comparison. So this is the 3D technique with high pressure, arc technique, high pressure, and you see that in all the places in the hallway, the energy decrease is higher when you use the arc technique. Maybe it is not very much, but you can see that there is at least, most certainly, you cool, because you take away the energy. So the idea that with arc techniques you cannot cool, that at least we can see that it is not true. So this is in the cold zone, because of course the discussion is about when you create the steam, probably the hot smoke layer will go down, yes, lower, and it will cause a temperature rise at the bottom where the firefighter is. Suppose the firefighter is crawling near the floor, and we can see that it is only very little. So there is a small increase in temperature and in energy near the firefighter, but it is only very little. It is at least not enough to burn, because that is what you see when you do nothing. You see, so there is a temperature increase, energy increase in the cold zone. So what we didn't know, but what we saw, was also that these techniques have an influence on the fire. And we cannot really completely understand what happens, but even when you start in the beginning of the hallway to do these techniques, to do the pulse or the arc technique, in both cases you have an influence on the fire, but you can see that the influence on the fire is a little bit higher when you use the arc techniques. So these are typical plots of the different techniques. So this is the this is the low pressure 250 liters a minute 3D pulse technique, long pulse, and that is the arc technique. I think that you can see at least the two curves that are very close together are two different experiments with the same conditions. So you can see that the reproducibility of our experiments was rather good, especially taking into consideration that fire is a live thing, so that you cannot really control the conditions always very well. Considering that, we think that we did a very good repeatability with the experiments. And what you can also see is that typical wave-like curves in the pulse techniques, which is of course understandable, because you open the nozzle and you close the nozzle, so you will have a temperature rise after you close the nozzle. Yeah, so that is what we already saw in earlier experiments also, and we were first surprised about that, but of course it is very understandable that you have it. But what you also see is after the start of using the pulse, it takes a little bit longer to have effect deeper inside the hallway. With the arc technique, it is faster, and you don't have these typical wave. So of course we have a lot of these kind of figures for every technique and every flow rate. We have them, and we process them according to a very difficult data analysis process to draw some conclusions. And I think the most important conclusion is, if you ask the question, can you cool the smoke using the arc technique with a straight stream, the answer is yes. So but in both techniques you can cool the smoke. But what we see is that with the arc technique, just open your nozzle, it is much easier to learn and much easier to perform. Although with a 450 liter a minute, you will need 2 persons and 1 person near the doorway, because that is rather heavy, already heavy work. But so we can see that maybe even the arc technique is a little bit more effective than the pulse technique. And at least what we didn't see, and sometimes you can see it, especially with the high pressure hose line and the pulse technique, you can see that sometimes the temperature behind the firefighters increases, which is of course not very good. And that is what we didn't see with the arc technique. So, of course, now, when we had these conclusions, we had a lot of discussion about steam, because then people started saying, yes, but if you use more water, you will have more steam. And there is a lot of also globally discussion about that, because what is steam? What do we mean by steam? A lot of firefighters talk about steam. So that's why we did that literature scan, to find proof that maybe the arc technique would have negative consequences if you start using it. But first I thought maybe it's nice to do a quiz, because then you can process a little bit all these things that I already said, and maybe all the questions you have about that. But what do you think? Is this an indirect attack? Hands up when yes. Fire prevention guys, you can also try to guess a little bit, you know. Yes, okay. Yeah. So yes, no, who says no? Only one person says no? No, okay, so this is not an indirect attack according to you. But I think the majority says yes. Yes, okay, so next question. Is this surface cooling? Who says yes? Nobody. Oh, one. No, okay, yeah, okay, this is surface cooling. Who says no? So, are there so many fire prevention advisors in this room? No, because I didn't see many hands, but or are you doubting? Who says, I doubt, I don't know? Okay, so that's the majority, because you, of course, you think that I'm tricking you, yes? Yes, okay, I understand. So remember your answer, yes? Because I will give the answers later, yes? Okay, so this, because I have another one. Is this smoke cooling? Yes, one, yes? Yeah, more, yeah, okay, yeah. And who says no? Lars, you're playing false. You did yes and no. Okay. That's a stupid question. So is this a direct attack? Yeah. Oh, yeah. No, we agree on that. Yeah, okay. So okay. Well, okay. So that's you know, when we started reading all the literature, which is not much. No, there is a lot of literature, but there is not much experimental research into this kind of matter. But there is a lot of literature, a lot of people that have opinions, and they are also very confusing, because they use definitions, and they don't tell us what they mean with their definitions. For example, this is an example. This is one picture that you can find, and it says 5 methods to attack a fire using water. The same picture, with the same effects, is to put out a fire. To put out a fire is not the same as attacking a fire. Agree? Yeah? Okay. But it still uses the same terms. So if you cool the smoke, do you attack the fire? Huh? Do you put out the fire? Okay, this is very interesting. It's just, you know, I hope I don't confuse you, but my conclusion is that these are very nice pictures, but you cannot separate all these effects. And there is also always, whatever you do, if you cool surfaces, you cool surfaces, you create steam, yes? Steam is to what side of the fire triangle? It dilutes, yes, it oxygen, it cools. So it seems that all these effects, it is nice try to separate them, but they have more than one effect on the fire triangle. So apparently it doesn't matter much, but it is very important in literature when people talk about indirect attack. It is not the same as what we saw sprinklering against the ceiling. It's not indirect. Indirect attack is what you saw in the movie. Indirect attack is smothering the fire using steam. The most important objective, oxygen. Yes, oxygen side. So that is the indirect attack. Direct attack is very, very easy. You put water on the fire as soon as possible. And then there is the surface cooling. Surface cooling, you should think like, okay, we cool the hot surfaces. No. It's about the fuel surfaces. So putting water against the ceiling is not surface cooling, and it is also not an indirect attack. So that is very important. Are you still there? So now you know what we had when we were reading the literature, because experts are talking and discussing effects that are confusing, because one talks about indirect attack and means something completely different than somebody else. When we call about surface cooling, one author means something completely different. And now all of a sudden I start understanding what Peter McBride says when he says we have to talk about literacy, because the definitions are not clear. And most important, I think, that it doesn't matter, because all techniques influence more than one side of the fire triangle. And that's why that fire triangle is still, for firefighters, really the most important thing to know, I think, to make it easy. So then we come to Lars, because Lars made me confused, also confused me, because he did an interview with Mats Rosander. You know Mats Rosander? He is a very famous Swedish fire engineer, and he invented, together with his colleague, which name I forgot, Mats Rosander, and Gisselson, yes, Gisselson and Rosander, they invented the pulse technique. And of course, according to fire safety engineering principles, it was theoretically very good, you know, because if you have very small droplets, they will evaporate more easily and you will cool more, because it will absorb more energy. Yes, it's very good. But his main reason to start doing this was because he saw that firefighters had burns. And he was telling about the Lehman method. So, of course, we started looking also in the Lehman method, because Lehman was the guy that invented the surface cooling, or maybe the indirect attack. Indirect attack using steam to put out fires. Yes, so you put a lot of fog, water, like we saw in the movie, inside the compartment. There will be a lot of steam and the fire will smother. Yes, because where steam is, there cannot be oxygen and there cannot be fuel. So it interested me. So, and he started telling in his interview, maybe you can find it on YouTube, the Swedish fire nerd. He has interviewed a lot of very famous experts on firefighting. And he tells that, so they used the Lehman method for the internal attack in Sweden, and they found out that sometimes firefighters got hurt by that. And that is why they invented the pulse techniques. But when you look into that further, he also says, so we did the indirect attack, go inside the building, close the door behind us, take 70 liters water a minute, and we were looking for the hot surfaces to create steam. With the door closed, and 70 liters a minute, and a lot of fog, and so a lot of steam inside the building. So we learned already that this was meant as an external attack, exterior attack, and not as an interior attack. So if you do this in an interior attack, you need to get rid of the energy. And if you close the door behind you, the energy will stay inside. So it is no wonder that firefighters got hurt. And if you do that with a very low flow rate, not enough to cool the smoke underneath the 100 degrees, then you will have a lot of overheated steam inside that compartment. So it is very important when people talk about smoke cooling and about burns and about steam, that you find out what was the exact situation that they were talking about. So here is your answer. So that spraying to the ceiling and trying to attack the fire is not an indirect attack. It is something that doesn't have a name until the transitional attack was found out, where you spray towards the ceiling and then have some kind of sprinkler effect. I think I make a mistake, because the upper side is the indirect attack, because you make a lot of steam. Yes, that is the idea, but you do it from outside the compartment. And this is not indirect, because that is a sprinkler effect. So then about steam. So there is a lot of confusion about steam. When firefighters talk about steam, it is, okay, I'm almost ready. So they, you have two types of steam. Yes, you have the transparent steam and you have the white vapory steam. And it's very important to see what is the situation that they are talking about. So if you use a lot of water, you will have a lot of wet steam, which has a low temperature. So that should not make it difficult for firefighters. If you use only little water, then all the steam will be in the transparent form. We will call it the dry steam. And the dry steam has a high temperature, so that will probably hurt firefighters. At least, when you look at all this, we didn't find any evidence in the literature about smoke layers that expand downwards to firefighters. So there is a lot of discussion about it, but we didn't find any evidence in the literature. So the conclusions from literature is that there is only few experiments, but a lot of literature. So there is a lot of experts that repeat what other experts already said. So there's a lot of opinions and a lot of myths, but there is not much proof to find in literature. There's a lot of mix-up in definitions, so if you talk to each other or you have discussions, please ask, what do you mean with this type of technique? What do you mean by steam, and what were the circumstances? Because the circumstances seem to be very important. How big is the flow rate? What kind of a stream? Did you use a pulse or a straight stream? So all these kind of effects affect the situation, and it is, and it is confusing when you just compare apples and oranges with that. Overall, and that was the idea of the literature study, overall we did not find any evidence that the arc method creates a lot of steam and could hurt firefighters. So that is, I think, the message that I wanted to give you. I hope that I did not confuse you with all these terms, but it was necessary to introduce to you that kind of things. So what we did in the Netherlands already is that we implemented the ARC method in our educational trainings. Instructors were re-educated and in refresher trainings. So the basic principles, the ARC methods and the stay low are already, hopefully most firefighters know about that. And yeah, maybe something to think about during the break. When I look at this like this, so you see the pulse techniques are very difficult to perform. Even experienced instructors find it difficult to not touch the ceilings and the walls. If you see that we have a long pulse, for the long pulse you will need a very small angle. Yes. So if you do like this, or you do pulses and you touch the ceilings, maybe it doesn't matter that much. Especially since smoke cooling only works in small compartments, not bigger than 70 square meters. You will always touch the walls. It is almost impossible to not do that. So maybe we are talking about something that is not so important. Maybe the most important is to open the door when you start extinguishing or start cooling to get rid of the energy. And that is maybe my conclusion, that we have, maybe this study brings us to this conclusion, that it doesn't matter that much what you do, as long as you cool the smoke. So, now, that is something to think about, and maybe we have a few minutes for some questions. And I hope I did not confuse you too much. And if I did, then you have something to talk about.
Okay, thank you, Ricardo. Questions? Sometimes you said, I'm still confused, but at a higher level. So yeah, Andrea.
Hello, Ricardo. Thank you very much. I have a question about, in the sustainability era, maybe there is also some drivers to save water. And I was wondering if you compare the use of water in the different techniques, and if you have any requirement in saving water when you, I know you're talking about safety,
Yes,
but
yes, yeah.
if you have to save water, compare different techniques. Thank you.
Yes. Well, we didn't look at that, of course. What we saw is when you use a straight stream and don't close the nozzle, you will use more water. But that was not the objective of this study. The study was to find out, can you cool the smoke with this kind, and that, of course, that is what the discussion is about, because a lot of people say now, yeah, okay, but you use more water. That is true. But when you use it in only small compartments, you will reach the fire very fastly. So how much more? It is not very important how much more. We think that especially in the sustainability environment, yes, where the dangers for firefighters, under-ventilated fires, fire explosions, fire gas ignitions are more important than the use of a little bit more water. But that was, of course, not the aim of this study. We didn't look, let's say that was not the aim. Yeah? Is that enough?
Okay. Yeah, Ruud.
Just wait.
Yeah, thank you, Ricardo. For me, it's really confusing
Yeah.
because this is why prevention and suppression always misunderstand each other, because we use different terms, and because you said it's very difficult for trained suppression to not touch the ceiling with the water, but. I think touching the ceiling, or maybe cooling the ceiling, cooling the construction, could be very effective for cooling the smoke layer. Maybe more effective than, in my opinion, direct cooling of the smoke layer with nozzle.
Yeah.
Did you also take that into account in your experiments?
Well, we didn't exactly look at the energy uptake of the walls and the ceilings in this case, because that became you need fire engineers to do that, yes. They can calculate. But this is exactly what is the discussion about, yes. So there is people that say, yes, but you cool the surfaces. So that's good because you prevent pyrolysis, and of course you also cool a little bit the smoke, but also the droplets fall down and they cool the smoke, but that is very difficult to measure. So I think that you are right. But on the other hand, people say when you have more smoke, of more steam, the smoke layer will go down, yes, and it will hit the firefighters. So that's yeah. But a lot of people say that the cooling the surfaces is not as effective as making very small droplets to cool the smoke. Yeah. And I think I agree with you, but I agree with you that that's why fire prevention and fire suppression sometimes don't match, because fire prevention uses theory, yes, and theory and practice. That is, I think, how to translate something that in theory would work very well into the practice. That's.
I think in fire engineering you use knowledge, and I think in fire suppression you use experience.
Well,
everything is based on experience. Apparently.
Yes, and on, yeah, no, yeah, okay, yeah.
Ricardo, I think you're talking about prevention versus extinction. If you think about one of the things, we are doing it on a theoretical basis if you talk about prevention, but at least we have terms and definitions that everybody talks in the same language. I think that would be something you might think about as well in the extension, that you think about how can we talk the same language and try to create some terms and definitions.
Thank you, Roy, because that was, of course, my attempt. So I hope that now everybody uses the same, when we are talking about that. That's, thank you.
Yeah, I guess it will not be easy to do that. But
Well, at least all of you will use the same language, I hope,
yeah.
from now on.
I had first here a question, and then I come to you, Lars.
Hello, my name is Dennis. I work for the Veiligheidsregio Havenlanden. Among other things, also a firefighter on the truck. And we used to have 1.7 system as well on our fire trucks. And I saw it was also briefly mentioned in your graphs, but I'm really curious, what are the cooling propositions in your experiment of 1.7 as proposed to water? I know this is a really brief presentation, so probably you can get into that, but I'm really curious about the, yeah.
Oh, but ask Thijs. Thijs, are you going to say something about 1.7? Oh, okay, because
Bad luck.
well, because let's say like this: there is still fire service regions that believe very much in the 1.7, but of course also the cooling capacity of 1.7 is depending on the amount of water which is inside. So there is a little bit more water inside the 1.7 foam than in the high pressure hose line. So we generally say that the cooling capacity of 1.7 is bigger than the high pressure hose line, but smaller than the low pressure. And that is also showed the cooling capacity, the smoke cooling capacity is also comparable, a little bit in between. Yes, but I think there was one graph where you saw the 1.7, isn't it? Yeah, okay.
I was also very interested because you heard so many different stories about 1.7. Some people just praise it and other people say it's completely useless.
Yeah.
And one of the arguments that were used in favor of 1.7 was always that it creates less steam, but it had large cooling capacity. So I'm just really curious what the outcomes in this experiment were.
Yes, and that is probably because the 1.7 was not meant to cool the smoke, but to put out the fire. So again, you see how important it is to, yeah?
Okay.
Lars, no difficult questions for me, I hope.
No, not. No, just about fire prevention and suppression. I think it's important to understand that fire suppression in prevention side, we talk like sprinkler systems. They are often discharged very early in the fire.
Yes.
And it's a whole different ball game compared to going manually doing firefighting when the walls are saturated with heat. So it's a whole different thing that to discharge a sprinkler system rather than manual firefighting. And the computer simulations are not done for very late suppression.
Yeah,
and
that's true.
the experience of firefighters being steam burned, a lot of fire prevention people have not experienced that, and it sucks. so it's not just we're making shit up, but it is. I think it's important. Then we just jump from cooling a little bit on the surfaces, which creates a lot of steam and steam burns, to cooling a lot on the surfaces. We didn't make that jump in Europe. We haven't had that experience of creating massive amounts of water on surfaces. So the experience of firefighters are, I would say, true. But it doesn't mean that necessarily that's the right way to go. Meaning, for instance, little water on just the smoke.
Yes, or little water on a steel wall.
Yeah, and that's another
which is
thing.
most of the experience. Yeah. Yeah.
Okay,
Thank you, Lars. Thank you.
So, yeah, we maybe should thank Ricardo for his presentation. And I try to walk down here. Thank you. And I guess there's plenty of time to discuss further at a higher level. Okay.